Hello everyone. Today we will going to see some practice questions from the topic redox reactions, and this is part 4. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. So we will see some practice questions from question number 22 to question number 29. Let's start with the question number 22. Among the properties A reducing, B oxidizing, and C complexing, the set of properties shown by Cn minus ions towards metal species is. We have to find out which are the properties from A, B, and C shown by the Cn minus ion, cyanide ion. Options are A, B, B, C, C, A, or A, B, C. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see what is the answer. So the correct answer is option C, that is C and A. So Cn minus cyanide negative is a better complexing agent. Okay, that is property C, as well as it is a good reducing agent, that is property A. Thus the property A and C are shown. So for property C, that Cn minus, 4 molecules of Cn minus ion combined with nickel 2 positive, giving us a complex compound, that is NiCN whole 4 2 negative. And according to the reducing agent property, property A, CuCl2 plus 5 molecules of KCN, giving us this complex K3CuCN whole 4 plus half of Cn whole twice plus 2 KCl. So in this reaction, we have Cn negative reducing Cu2 positive to Cu positive, right? So it is acting as a reducing agent, and thus these are the two properties, property C, that is the complexing property, and property A, that is reducing property, which is shown by the C negative ion, and thus the correct option is C, that is C comma A. Okay, let's move to the next question, question number 22. 23. 22 was last question. This is question 23. So which of the following is a redox reaction? We have given some reactions. Find out which is the redox one. Options are formation of glucose from CO2 and water, reaction of potassium cyanide with silver cyanide, hydration of rubidium, or reaction of barium chloride with sulfuric acid. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer will be option A, that is formation of glucose from CO2 and water. So you can see this is the reaction here given for the formation of a glucose at molecule from CO2 and water H2. So 6 CO2 plus 6 H2O in the presence of sunlight, giving us a molecule of glucose C6H12O6 plus 6 molecule of oxygen. So in the CO2, carbon is in plus for oxidation state, and it is reducing to carbon in the zero oxidation state in the glucose. So this is the reduction happening here. And from H2O, in H2, oxygen is minus 2 state, but from this, oxygen is going to zero oxidation number in the O2 molecule. So the oxidizing or oxidation number is increasing. That means the oxidation is happening in this process. So as in a single reaction, both oxidation and reduction is happening simultaneously. That's why this reaction will be known as redox reaction. So the formation of glucose from CO2 and water, and since oxidation reduction both occurs simultaneously in the above equation, so it is a redox reaction. Okay, and thus our option A is the correct answer. Okay, let's move to the next question. Question number 24. Which of the following is a redox reaction? We have given some reactions in the option in which we have to find out which one is the reaction which is redox. Options are sodium chloride plus potassium nitrate giving us sodium nitrate plus potassium chloride, calcium carbonate plus 2HCl giving us calcium chloride plus H2C2O4, CaOH whole twice calcium hydroxide plus ammonium chloride giving us calcium chloride plus ammonia plus water, and twice of KAgCN whole twice complex compound plus zinc giving us twice of Ag plus K2ZnCN whole 4. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option D, that is twice of KAgCN whole twice plus zinc giving us twice of Ag plus K2ZnCN whole 4. In the A option, which is NaCl plus KNO3 giving us NaNO3 plus KCl, Na is in plus 1 oxidation state, Cl will be minus 1, K will be plus 1, oxygen will be minus 2. And in the product side, Na will be plus 1, oxygen will be minus 2, K will be plus 1, Cl will be minus 1. Right? You can see there is no change of oxidation state. Oxidation number is happening from reactants to the products. In B option, CaC2O4 plus 2HCl giving us CaCl2 plus H2C2O4. Here, calcium is in plus 2 oxidation state, oxygen is in minus 2, hydrogen plus 1, chlorine minus 1. Similarly, in the product side, calcium plus 2, chlorine minus 1, hydrogen plus 1, oxygen minus 2. So, in this reaction also, you can see that no change of oxidation number is happening for any of the elements present in this reaction. Similarly, in the reaction C, CaOH whole twice plus twice of NH4Cl giving us CaCl2 plus 2NH3 plus 2H2. And here the oxidation number of calcium is plus 2. The oxidation number of OH is minus 1. And for nitrogen, it will be minus 3. For hydrogen, plus 1. Chlorine, minus 1. In the product side, calcium is plus 2. Chlorine is minus 1. Nitrogen is minus 3. Hydrogen is plus 1. Hydrogen plus 1. Oxygen minus 2. So here also you can see that no change of oxidation state is happening from the reactant to the product side. So in all these reactions, that is A, B, and C, during reaction, there is no change in the oxidation state or of ion or molecule or constituent atom, right? Therefore, these are simply ionic reactions. So these are A, B, C. These are ionic reactions given in the option A, B, and C. And in the D option, we have given twice of K AgCN whole twice plus zinc, giving us twice of Ag silver plus K2ZnCN whole 4. And in this, Ag positive is giving us Ag molecule, Ag atom, you can say, right? So here it is in 0, here it is in plus 1, silver. Plus 1 to 0, that means gain of electron, and reduction in the oxidation number, that means reduction is happening. Similarly, zinc is in 0 state, and here it is going into plus 2 state. So the oxidation number is increasing, that means oxidation is happening and loss of electron is happening, right? Because from elementary zinc, it will going to become an cation that is N2 positive. So both oxidation and reduction is happening in this reaction, option D. So the option D is the correct answer. That is, this is the correct reaction in which oxidation and reduction both are happening. That's why this is a redox reaction. And thus D option is the correct answer. Okay, let's move to the next question. Question number 25. For the redox reaction, MnO4 minus plus C2O4 2 minus plus H plus, giving us Mn2 plus CO2 plus H2. The correct coefficients of reactants for the balanced reaction are. So we have to tell the coefficients, stoichiometric coefficients for the reactant in this reaction to be balanced, for the reaction to be balanced. Okay. Options are, uh, for MnO4 negative 2, C2O4 2 negative 5, H positive 16. MnO4 negative 16, C2O4 2 negative 5, H positive 2. MnO4 negative 5, C2O4 2 negative 16, H positive 2. Or MnO4 negative 2, C2O4 2 negative 16, or H positive 5. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is the coefficient for MnO4 minus reactant is 2, for C2O4 2 minus reactant is 5, and for H positive it is 16. So this will be this is the reaction MnO4 minus plus 8H plus 5 electron, giving us Mn2 plus 4H2. Okay, so we just divided this single reaction given in the question in the two half reactions. So second reaction will be C2O4 2 negative, giving us 2CO2 plus 2 electron, right? Because for balancing, what we will do, we have studied this in the oxidation rule, that if we have an ionic reaction, we have to divide it into two, in the cation and anion, and then we have to balance the electrons by multiplying with a suitable integer, to balance both sides, hydrogen and oxygen, right? So we are doing the same. So in the first reaction, we will multiply it by 2, and the second reaction, we will multiply by 5, and then we will balance it. So the final reaction which is coming out is this, that is Mn2MnO4 negative plus 5C2O4 2 negative plus 16H positive, giving us 2Mn2 positive plus 10CO2 plus 8H2. And thus the coefficient of MnO4 negative, C2O4 2 negative, and H positive in the above balanced reaction, as you can see respectively, are 2, 5, and 16, right? And thus our option A is the correct answer. Okay, let's move to the next question. Question number 26. C2H6 plus NO2 giving us CO2 plus H2. In this equation, the ratio of coefficients of CO2 and H2 is. Options are 1:1, 2:3, 3:2, or 1:3. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option B, that is 2:3. So the balanced equation for the given reaction in the question is twice of C2H6 plus 7O2, giving us 4CO2 plus 6H2. Right? If you see that carbon here is 4 in the reactant side, in the product side carbon is 4. In the reactant side hydrogen is 12. In the product side hydrogen is 12. In the reactant side oxygen is 14. In the product side we have 8 plus 6, 14. Okay, so we have equal amount of each atom. And so ratio of coefficients of CO2 and H2 we have asked, right? So CO2 coefficient is 4, H2 coefficient is 6. So 4:6. That is 2:3 in the simpler ratio. Therefore, the correct answer is option B, that is 2:3. Okay, moving to the next question. Question number 27. So it is given that X Na2HASO3 plus Y NaBrO3 plus Z HCl, giving us NaBr plus H3ASO4 plus NaCl. We have to find out the value of X, Y, and Z in the above redox reaction respectively. Okay, so we just have to balance it. We just have to match the number of atoms present in the both side reactant and product, and we have to balance it. It should be equal in the reactant and product, right? Options are 2, 1, 2, 2, 1, 3, 3, 1, 6, or 3, 1, 4. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is 3, 1, 6. So this is the balanced reaction, given reaction. 3 Na2HASO3 plus 1 NaBrO3 plus 6 HCl, giving us NaBr plus 3 of H3ASO4 plus 6 of NaCl. So the X is 3, the Y is 1, and the Z is 6. So C option, that is 3, 1, 6 for X, Y, and Z value is the correct answer. Okay, let's move to the next question. Question number 28. Consider the following reaction. We have given a reaction here. X of MnO4 negative plus Y of C2O42 negative plus Z of H positive, giving us X Mn2 positive plus 2Y CO2 plus Z by 2 H2. Right? Again, we have to find out the X, Y, and Z value in the reactions respectively. Again, we will balance it. So options are 2, 5, and 8, 2, 5, and 16, 5, 2, and 8, 5, 2, and 16. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. The correct answer is option B, that is 2, 5, and 16. So this is the reaction which we have balanced, that is twice of MnO4 negative plus 5 of C2O42 negative plus 16H positive will give us 2 Mn2 positive plus 10 CO2 plus 8H2, right? And as you can see that X value is 2, Y value is 5, and Z value is 16, right? So 2, 5, and 16 is the correct answer, and thus B option is the correct one. Okay, let's move to the next and last question, that is question number 29. We have given assertion and region statement. So assertion is oxidation number of chromium in CrO5 is plus 6. Region, oxidation number of each oxygen atom is minus 1. Options are assertion and region, both are correct statements, and region is correct explanation of assertion. Assertion and region both are correct statements, but reason is not the correct explanation of assertion. Assertion is correct and reason is incorrect. Both assertion and reason are incorrect. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is assertion is correct and reason is incorrect. So in the molecule CrO5, 4 oxygen atoms are in -1 oxidation state. So this is the diagram given here for CrO5. Cr attached to 1 double bond to the oxygen and 4 single bond to the oxides, right? For each this type of oxygen, the oxidation state is -1, -1, -1, and -1. And for this double bond oxygen, we have the oxidation number for this oxygen will be -2. Let's suppose X is chromium, and let's solve it. So it will be X plus 1 times -2 and plus 4 times -1 is equals to 0. Okay. On solving this, X is coming out as equals to +6. Right? So oxidation number of chromium in CrO5 is +6. So assertion is true. Oxidation number of each oxygen atom is -1 written in the region is incorrect, because each oxygen atom is not -1, only 4 oxygen atoms are -1. Right? So reason will be false, and thus assertion is true and reason is false. Thus our C option is the correct answer. Okay. Okay. Thank you.